Hey, good morning mga matindi. So in this video, we'll know how to derive a certain formula or a certain rule based from the given condition, or based from the given, let's say from the given sequence or numbers or list of numbers. Okay, so actually in mathematics, it is not only about knowing how to use the formula, but it is also a matter of knowing how or where this formula is taken from or derived from. Just like what I am using or I am doing in my subject. Before I teach students how to use that formula, I let them derive, or I show to them. If they can't, I show to them how to derive formula. Okay. Any topic that needs derivation of the formula, you have to derive that before you teaching them how to use it. Okay, so in this video we'll know how to derive this rule in finding any term of an arithmetic sequence. Okay, so let us start. So if you have a sequence 4, 7, 10, 13, okay, let's say you have another 16 and another you have, this is an infinite arithmetic sequence. Okay, so let us first have the first term. So we have, the first term is, we have a sub 1, that is 4. Okay, then a sub 2, that is 7. But this 7 can also be written in terms of a sub 1, 4. We can have 4 plus 3. Right? Okay, next, we have a sub 2, a sub 3 rather. A sub 3 is 10, but this 10 can also be written in terms of a sub 2 with 7. We can have 4 plus 3 plus 3. Another, we have a sub 4. Now, a sub 4 here is 13. So, 13 can also be written as 4 plus 3 plus 3 plus 3. Right? So, we have 4 terms here, but I guess you now can see the pattern. If that, let us proceed. A sub 5 is 16. And this 16 can also be written in terms of, again, in terms of a sub 1 with 4, a sub 2 with 4 plus 3, a sub 3 for 4 plus 3 plus 3, and a sub 4, 4 plus 3 plus 3 plus 3. So we can have 4 plus 3 plus 3 plus 3 and plus 3. So if you sum it up, it is equal to 16. Okay? Now based on the pattern, let us have this one. Yeah. Have you seen any pattern or any number that is being used as a constant? Meaning that constant will be our common difference. Okay, common difference that is actually used in arithmetic sequence. Okay, so you have here 4, that is plus 0, 3, and we have 4 plus, how many 3s do we have? 1. So you have 1. Okay. Next, we have 4 plus, how many 3s? We have 2. So you have 2. Ganyan. And then you have here 4 plus, how many 3s? We have 3. So you have that one. Another, we have 1, 2, 3, 4. So you have 4 plus 4 3s. So based on this list of patterns, or based on the process that we have done, what have you noticed? What have you noticed in terms of number of 3s that are used, or the number, repetitive number? Okay, so if a sub 1 we have 0, 3. If we have a sub 2 we have 1. If we have a sub 3, then we have 2. If we have a sub 4, we have 3. And if we have a sub 5, we have 4. Okay. Now this number 3 is our, okay, ito yung mga 3, this is our D, common difference. Okay? So therefore, based from this expression, if I have here a sub 6, then I can have, since it is just subtracting 1 from this subscript, so I can say that since all of the terms has or have 4, so we can say that it is equal to 4 plus 5. 3. Now let us analyze. If I have a sub 7, then a sub 4, what is a sub 4 in our expression or in our sequence? What is 4? What is 4 in the given sequence? It is the a sub 1. So we can now replace 4 by a sub 1. This is a sub 1 plus, what is the relationship between this 1, this 5 to the n term? That is minus 1. So therefore, if you have, let us have this 1. So 7. 7, this will become 6 and a common difference. Okay? Let us try. If you have this 1, 6. I have a sub 7, then I have here 6. So therefore, I can say that if I have a sub n here, then I can use now a sub 1 plus, if this is 7 becomes 6, that means 7 minus 1. So therefore, we can have here n minus 1. Okay, so therefore you have n minus 1 times the common difference. So that's how you derive this formula. See? A sub n is equal to a sub 1 plus n minus 1 times the common difference. And now, you can, through the use of this derive rule, you can find any term of the given arithmetic sequence. Okay?